Okay, let's go ahead and get started. My name is Eric Siebert. I'm a solutions manager for HP Storage. I thank you for sticking around to attend this session. I promise you'll learn all sorts of great information about VMware virtual volumes. Before we start, just kind of curious, is anybody actually using or tried out virtual volumes today in their environment? A couple hands. Anybody want to, but their array doesn't support it yet? And I know, I see a lot of hands there for that. There's definitely a lot of arrays that are still, a lot of vendors out there that are still trying to catch up and get support for that. I expect you'll see that more and more over the coming months. So here's the agenda. I'm just going to kind of skip over this as there's a lot of material to cover here. So let's just dive right in. Kind of before I start, just wanted to point out kind of our involvement with virtual volumes. At HP with 3PAR, we've been actually working with VMware as a design partner on virtual volumes before the HP acquisition of 3PAR. So we have a lot of experience. We've been, day one we had support for virtual volumes with vSphere 6. And so we've been, and I've been personally involved too for quite a while on that. So we have a lot of experience implementing virtual volumes. So first off, let's take a look, why do we need a new storage architecture? In the beginning, VMware created VMFS. And VMFS was really about more of the new type of file system that would support the unique nature of a VMware environment with many hosts all accessing a single LUN and accessing the same files on that LUN. So VMFS really wasn't designed for the kind of things that we're doing with virtual volumes. If you look at it, it's very LUN-centric in that we're just carving up our storage arrays, creating silos within our arrays. The storage array has absolutely no visibility into what goes inside, what's going on inside a virtual volume, or inside a VMFS volume. It can't see the VMs inside there. Poor efficiency, typically we're over-provisioning storage. We always are saving spare capacity on our LUNs for our volumes. We don't want to run out of space. Increases our administration. We can't really reclaim space. There's a command line utilities reclaim space in vSphere. But it's really a pain to do that, and because the array has no visibility, it can't automatically reclaim that space. Hardware-centric, typically we're managing our storage with vendor-specific storage tools on the storage array side. Provisioning cycles are longer, and those data services aren't really aligned with individual virtual machines. So if you look at VMware's goals of, why did they think a new storage model was necessary, really it was all about getting that application level granularity, really kind of bridging the gap between virtual machines and the storage array and allowing the storage array to be able to interact directly with those virtual machines. Kind of the value prop there is, simplified management. We're only managing storage in one spot. We're not having to do it on both sides. Better SLAs because we can do a lot more fine-grained control of our storage resources by applying storage array features directly to individual virtual machines. And improve efficiency because we're not over-provisioning storage. We're only using what we need. We can reclaim space. So all in all, there's just a lot of benefits to virtual volumes. And VMware, really put a lot of effort into, creating this new operational model to be able to, better have storage better interact with virtual machines. So if we look out, VVols Transforms Storage, what it does compared to the old way with VMFS, virtual volumes is now VM-centric. It's no longer really LUN-centric. We're dynamically allocating storage. We're not having to pre-allocate storage. We're only using what we need when we need it. There's no storage pools anymore. We're not carving up our storage array anymore. We're not creating those LUNs, those silos, putting VMFS on top of it, and then putting the VMs inside of those. We're simplifying management by only managing on one side, on the vSphere side. Automatic space reclamation, I'll talk about that more later on. That's a big one. We can now automatically reclaim that space. We're using vSphere-specific management tools instead of storage array tools. Provisioning is a lot quicker. We don't have to go back and forth to a storage admin and say, hey, I need more space on this volume. It's all now automatically done. And then the big one is we're aligning all those rich array features and services directly to individual virtual machines. So if you look at kind of the comparison of a VMFS compared to a VVols applying array features, with VMFS, things like replication or snapshot, if I wanted to do that, I had to take it on the entire volume. So all my virtual machines, whether I wanted them snapshotted or not, were all included in that snapshot. Things like replication. If I want to replicate the whole volume, I can, but if I only want to replicate certain virtual machines, I can't really get that granularity. With VVols now, I can pick and choose. I can apply those features only to the virtual machines that actually need them. So, like I said, the storage array features now really shift to the vSphere side. With VVols, storage isn't really designed anymore to be managed really at all, or not that much, by the storage admin. So anything I do, like creating a VM snapshot, I'm still going to do it, so the features are actually still used and kind of done on the vSphere side. But what happens is now on the storage array side, because of that link between the vSphere and the storage array. So creating a VM snapshot, I'll still go into the vSphere client, click Take Snapshot, but it'd actually be a storage array snapshot taken on the backside. Same with thin provisioning VMs. I'm not doing that in vSphere anymore. It's on the array automatically, creating virtual disk, deleting VMs. All that is initiated on the vSphere side, but all the operations all happen on the storage array side. So let's dive into the architecture and components. This is a key one to help you really understand what VVols is all about. There's a lot of different components if you're familiar with VMFS. There's a lot of new things added into VVols. So we'll start at the base, and that's the protocol endpoint. What the protocol endpoint is the data path between your ESXi host and the storage array. It's essentially a logical I/O proxy. It's protocol agnostic, so it's not specific to any one protocol. So it kind of works within any protocol. And that's where all my data movement happens between the host and the storage array. And I'll talk about the PE more detail in the next slide. The VASA provider, that's my out-of-band control mechanism between vCenter, the host, and the storage array. So things like passing information I need from the storage array to ESXi all happen through that VASA provider. When I power on a VM, that VASA provider is used to bind the VM to its VVols. So that's another key critical component. And that VASA provider can live either within a storage array internally or externally. And a thing like some of the vendors out there are implementing them in virtual machines. So it's got to be somewhere between the host and vCenter and the storage array. But it's up to the vendor to choose where they want to implement that. Storage container. Storage container is kind of a logical entity. It's that pool of raw storage capacity on the back-end storage array. So the storage container, we're not allocating any storage to it. It's simply just a logical thing on the back end where we put our VVols in. So like I said, it's not like we're actually carving out space and giving it to the storage container. When you create a storage container, it's essentially going to have the entire capacity of the array available within it. Next one here. Oops, back one. And then the virtual volumes themselves, and we'll talk about those more on the next slide. Those are there's different types of virtual volumes. A VM is made up of more than one type of virtual volume, and that's basically the encapsulation of, if you're familiar with VMFS today and all the files we have in there, a VVol essentially is the encapsulation, the container essentially, where we store the VM objects inside. And then finally, the storage profile. And that's kind of the glue that takes together our storage array capabilities and allows us to assign those to virtual machines. That's on the vCenter side where we create all our policies. Once we import all of these storage array capabilities into vCenter, now we can pick and choose what capabilities we want to assign to policies and then assign those policies to virtual machines. All right, so meet the VVols. Let's start with the first one. Like, meet the parents. The config one. Now, if you're familiar with how it's done in VMFS, we had a subdirectory for a VM with a bunch of files in it. So this is kind of similar to that, but we're packaging things a little bit differently. So the config vVol, similar to that text file, that VMX file we had inside of VMFS, it contains all the configuration data for the virtual machine when I go and assign it, different hardware characteristics. That all gets written to this file. But unlike the VMFX file, it also contains more data. It contains the disk metadata, which was previously a separate VMDK file that was there. That's all bundled into here. We have the VM log files that were all separate before. That's bundled into the config vVol and any other lock files we have. It's provision thin. It'll grow as needed. It can grow up to 4 gigabytes. There'll only be one per VM, and that file, as it grows, it'll never exceed that max size. It'll clean up within it to keep it under that 4 gig. The data one, and that's similar to a VMDK. So essentially, that's our virtual disk. There'll be, It's essentially just a raw disk file. It's also used for when we take a snapshot of a VM, you'll see another data VVol created for that virtual machine. The max size of that is up to 64 terabytes, which is in line with the max size of a disk file in VMFS. Provision thin, but it can be made full, and that you still have the options to do thick or thin there, but it's provision thin. And there'll be one for each VM disk and snapshot. And I'll talk about kind of the limits and how many will actually get created for a VM later on on another slide. And at a minimum here, when you first create a VM, there's going to be two VVols, the config VVol and the data VVol. So that's what you're going to have at a minimum. That's what you're starting with. Once you power on a VM, you'll have this additional VVol here, the swap VVol, similar to the memory vSwap file that we have today with VMFS. It gets created for memory over commitment on a host. If the host runs out of memory, we got to use disk for memory, and that's why that file is created. That one's provision thick because we don't want to have to expand it because it's memory. We need it to move faster than that. So it's provision thick, or provision, yeah, full thick. The max size of that is 4 terabytes, which is in line with the max size of memory that you can assign to a virtual machine. So that file will actually just be whatever the size of memory that is assigned to a virtual machine. So equal that. So if it has to make up for memory, it could do that with that file. And there'll only be one of those for each virtual machine. Finally, the memory one. And this is similar to, if you're familiar today, if you take a snapshot of a VM, or if you suspend a VM and we want to preserve the memory state of VM, the memory VVol will do that. That's where we store all the memory contents in that one. That's provisioned full as well. That max size, again, is the max size of 4 terabytes, which is the amount of memory we can assign to a VM. It'll actually equal the size that you have assigned to the VM, though. And there'll be one for each VM if you suspend it, and that, or one for each snapshot. So if I'm taking multiple snapshots and including the memory state in that snapshot, there'll be one of these files for each of those. Okay, so talked about Protocol Endpoint a little bit more. So what we actually do when we power on a VM is we have to bring together the VVols to the host. So that's called a bind operation, that we go out there and we're going to bind that host to the specific VVols of that virtual machine that we're powering on. So the Protocol Endpoint is used for that, and that's essentially it's a special LUN on the host, in that we're not actually, it's a LUN, but we're not allocating any storage to it at all. It's a special LUN that has a special bit set. It's called a LUN conglomerate bit, and what that does is essentially acts as an administrative LUN that the Protocol Endpoint interacts with. Then under that we have sub-LUNs, and those sub-LUNs are actually what are assigned to the individual VVols. So in our case with 3PAR, we assign that LUN an ID of 256, one above the 255 LUN limit that ESXi has today. But essentially then once you power on the VMs, that VM gets bound to those individual virtual volumes. And all that sub-LUN information or secondary LUNs all gets funneled up through the VASA provider. So I think I have an illustration here that'll kind of show you how that all works. Let's see. I don't think it's timed, but so essentially what will happen is first is we'll go out and the host will connect to the protocol endpoint. Let's play it out once here. Come on. Then it's going to go over to vCenter and say, hey, I need to know the sub-LUNs and that. So I need to be able to bind to those specific sub-LUNs, because the ESXi host on its own is only connecting to that protocol endpoint, that special LUN, and that those sub-LUNs that are underneath it, it needs to discover those. So it's going to go out to the VASA provider and query to say, hey, give me the sub-LUNs, and I'll go out and find it for the specific VM. Once I have those, I can then go bind the VM to its VVols. And then once I power off the machine, we're unbinding. We're disconnecting that host to the virtual volumes. And then when we power it on again, that operation completes again, and we bind it back. So storage policy-based management is the other kind of big component with VVols. If you're familiar with vSAN, that's where VMware first introduced storage policy-based management. And what that, again, essentially does, as it does for vSAN, it's the same exact engine. They're not using anything different there. Is allow us to, again, take those array capabilities and kind of put them into a storage policy and create different policies and then assign them to virtual machines. So once we create these policies, assign them to a virtual machine, the storage policy-based SPBM engine then will make sure that that VM is on a compatible data store that meets the requirements of those policies. So the way it works basically is just the array through the VASA provider. We're going to tell the array everything, or tell the VASA provider everything we do. So we're going out there and say, hey, we support thin provisioning, we support snapshots, and we're funneling all those up. We then go into vSphere, create a policy. I'll go through and pick and choose, kind of like a menu, what I want to assign into that policy. And then once that policy is created, I'll simply assign that to a virtual machine. And like I said, well, we can create these different policies, based on certain SLAs I need for a VM. If I want to create a special high-performance tier on SSD storage for one policy, another one maybe on nearline storage, less critical VMs, I can kind of pick and choose all of those features, both hardware characteristics and array features, and put them within these policies. So compare now to VMFS, this is kind of show you what's different there. With VVols, really designed to be managed by the vSphere admin. We're not really going to the storage admin anymore, except for the initial setup of the storage container. Full policy-based management of the VASA 2.0 specification. If you're familiar with the policies that were in VASA 1, they weren't very useful. I don't think anybody really used them, and that you couldn't really do much. What we passed from the array to vSphere on VASA 1.0 was simply just a string of a bunch of capabilities, and you really couldn't do much with it. So VASA 2 was all created and written specifically for VVols to really enhance the way we can communicate between the host and the storage array. So vSphere features get applied per VM instead of per LUN. They both support VAAI, but it's different, a little bit different with VVols. And I got a slide that'll cover that. It'll tell you the different characteristics of VAAI with VVols. Replication is one of those things that isn't supported yet. That's not really the vendor's fault. That's more of on VMware. They haven't built that into the VASA 2 specification today. The next version of VASA and vSphere that comes out will fully support replication. But at this point, you can't do array replication through the SPBM. You can still do it on the back end if the vendor supports it. They can go back and do it, but it's not integrated with vSphere the way it would be if it was in the specification. So consequently, there's no support for SRM or vSphere Metro Storage Cluster. There is no support for direct-to-SAN backup. If you're familiar with the backup applications that would go right to the SAN to back up VMs, that's not there today. There are other methods to do backups via the virtual disk development kit that was created and updated for VVols, and some other methods to do that. So that doesn't change too much. You can still do your backups, and I'll talk more about backups in a different slide. Doesn't support VC ops, vRealize ops. Today, I'm sure that will come at some point. And then automatic space reclamation, which I'll talk about on another slide, that is fully supported and automatic now, where it wasn't before. We had to run ESXi to try to reclaim space on a bulk basis. So looking at some of the max limits compared between VMFS and VVols. So the size of a virtual disk hasn't changed. Still 64 terabytes is our limit on both. The number of VVols bound to a host is 4,000. So one VM will be multiple VVols. A host can see more VVols than that, but at any one point in time, it can only bind to 4,000. The number of PEs or LUNs is the same on both. Storage container size is a ridiculously huge number. If you remember VMFS, the max volume size is 64 terabyte. But the storage container, since we're not carving anything up more, it's basically just the capacity of the array. So it's a really high number. So you're not really limited there to the size of that storage container. And then you can have the same storage containers per host as you can volumes per host. So the max VVols per storage array is really up to the vendor to decide. Each vendor has their own limits for what they can support, based on their capabilities within the array, and that can range. I've seen some as small as 1,000 or 2,000, up to some vendors in the hundreds of thousands or millions. Expect as these evolve on the arrays that numbers will continue to increase. The theoretical max VVols in vSphere cluster is 19 million that you could have. And that's really just by doing the math of the max virtual disk per VM, which is 60, times the max number of snapshots per VM, which is 32, times the max number of VMs per vCenter server, which is 10,000. The max VVols for a powered-on VM, so a single VM, can have up to around 2,000 VVols. And that's the math on that is you always have one config, you always have one swap. You can have up to 60 data based on the number of virtual disks that you can assign to a VM, which is 60. Up to 1,920 snapshots, and that's based on the up to 60 disks versus 32 snapshots. Multiply those together. And then up to 32 memory states for when you take snapshots. Now, typically, I've seen averages, people saying they may have up to, it's really dependent on how many snapshots you're going to have in your environment. At a minimum, when a VM is powered on, you're going to have 3 VVols, the config, the data, and the swap. But the more snapshots you take, the more VVols you're going to have. So really take a look, when you're planning on VVols, see what you use for snapshots, kind of look at your vendor and see how many they support, because that's really going to impact how you're going to be able to, how many VMs you're going to be able to put on that array using VVols based on the number of VVols that array can support. So we look at requirements and compatibility. This is straight off of VMware's knowledge base article and their hardware compatibility guide, which tells which features are supported and which VMware products are supported with VVols and not supported, and which vendors support VVols. There's a special, if you go to the VMware hardware compatibility guide, there's a special category there for VVols. If you look at that, you'll see all the vendors support it and kind of some information about their implementation. So the big ones on VMware side that's not supported right now is vRealize Operations Manager and Site Recovery Manager, simply because we don't really support that replication piece yet. The vSphere features that aren't supported with VVols, storage I/O control, which we can do that on the array side, so that one's not terribly important. NFS version 4.1, if you're familiar with vSphere 6, they introduced support for 4.1, which has some enhanced stuff like PNFS in it. It's not supported yet on VVols. FT, fault tolerance, array-based replication, and then RDMs aren't supported on VVols as well, since there's no SCSI reservation support on VVols. Vendors support it. Still a pretty small list in that. It's grown a little bit. I think EMC announced that they're coming in the middle of next year or something. We've supported it since day one. I think there was only 4 vendors on day one of vSphere 6 launch that supported it. We're one of them as a design partner. We were pretty well ahead of the curve. But that always changes. So if you want to see if your array supports and what firmware is required to support VVols, check the VMware hardware compatibility guide. Check with your vendor to see their roadmap supporting VVols. So the requirements for VVols. So the host obviously must be running ESXi 6.0. You also have to have a vCenter server 6.0 because of the VASA provider. It needs to be able to use that and communicate with that. Your array firmware must support VVols, and again, check with your array vendor. You may need an upgrade to be able to support that. You must use a supported storage protocol, and that varies by vendor. I know with us, currently we support Fiber Channel with VVols. We'll be introducing iSCSI support soon. But if you go to the hardware compatibility guide, again, it'll show you what protocol is supported by each vendor, by each array model. So you'll know there exactly what protocol is supported for whatever array you're implementing VVols on. It does require an HBA driver that supports that new secondary LUN IDs. VMware went out and created some new T10 stuff specific to supporting these sub-LUNs and that. So a lot of the HBA drivers are catching up on that. So I know in our case, we've seen a lot of customers that have tried to implement it. They can't see the protocol endpoint simply because it doesn't support that secondary LUN ID. So make sure you check with your HBA, because you'll see an error actually if you try to use VVols. If your array supports it and the host supports it, I forget the error, but it's something about the protocol endpoint not supported. You'll see that error if your HBA driver isn't supporting those secondary LUN IDs. Storage array must be capable and licensed to support thin provisioning and snapshots. So we're shifting all the vSphere features to the array. So we can't use vSphere thin provisioning anymore. We have to use array thin provisioning. I know in ours, we include thin provisioning into our core OS, but some other vendors might charge you extra for it. So check with your vendor, because you may have to license thin provisioning to be able to use this. And snapshots, again, we're not doing VM snapshots anymore on the vSphere side. They're all array snapshots. When they take a snapshot of a VM in vSphere, it's an array snapshot. So again, you may have to license that on your storage array, so check with your vendor on that. And finally, there's a special port that vCenter uses. Just you have to keep open on the firewall, the UDP port 9 for communication. Snapshots and thin provisioning, one of my favorite kind of new features with VVols that I think really adds a lot of benefit here. If you're familiar today with how snapshots are done on that, what we're doing when we take a snapshot on VMFS is going out and we're going to freeze that base disk. That base disk is going to be read-only. Let's see my animation will play. Okay, there it goes. So the base disk becomes read-only when we take a snapshot with VMFS. And any subsequent snapshots, the last snapshot will be read-write. That's where we're actually writing our data to, and the snapshots before that will all be read-only. So once we go and actually delete those snapshots, what happens is we got to roll them all back into the base disk, which can be very time-consuming. If you've ever had a snapshot sitting around in vSphere for weeks or months, there could be a ton of data there that has to be rolled all the way back into there. Takes a lot of time, takes a lot of resources, really kind of a pain-in-the-butt process to delete snapshots today. So once we roll everything back into the base VMDK, then those snapshot files are deleted on VMFS. So with VVols, the way that now works is when I take a snapshot, my base VVol, my base disk, stays read-write. And that we're not going to freeze that disk anymore. Any new data is still going to get written to that. And then what happens is any new change blocks that occur within that base disk get written out to my Delta files. So my Delta files are always read-only now. And my base disk contains the most latest and greatest data within it. So now when I delete the snapshot, what happens is I no longer have to roll everything back into my base disk. I just, boom, they're gone. You know, we don't need them anymore. So operation is just like that. It's instant in that we don't have to wait hours or however long to get all that data rolled back in there. So efficiency-wise, this just works a lot better. That we're not having to go and have to those resource-intensive operations. The snapshots are much more efficient on the storage array. So snapshots are one of the, I think, the best features with VVols now is since that all shifts to the storage array, it's all done a lot more efficiently, and we save a lot of time when we're going through and deleting them. And that also has a big impact on your backups. There was a semantic session as well, and they were talking about how they've done testing. They found the backups operations have completed a lot faster simply because, again, they don't have to wait for things to roll back into that base disk because when they take a backup, they have to freeze that disk and take a snapshot, and now they don't have to wait for all that to roll back. Boom, it's just done instantly once we delete that snapshot. Where are we going? Okay, so yeah, the benefits then of that, just like I mentioned, it's more efficient on the storage array. The storage array can handle snapshot a lot better than vSphere can. We're not sucking up host resources when we're creating snapshots. With a snapshot, every time it grows, we got to allocate more space when we did it on VMFS. And then when we commit it, we're using host resources again that we're taking away from our workloads. You're not having to do that anymore on the array-based snapshots, not waiting hours to commit. No chance of really lost data. When you have that chain of snapshots, multiple ones, your live data is spread across multiple snapshots. The way it is with VVols, it's all on one disk in that. You're not having to worry about having those all rolled back and maybe something happens when that operation is occurring. It's all just simply you delete the data today with VVols and you don't have to worry about that roll-up. The base disk remains active, and there's really no performance drop. We've seen with 3PAR that you're not really having any impact at all using snapshots like you did with VMFS. So definitely a lot more efficient and effective. So if you look at thin provisioning with VVols, like I said, we're no longer managing that. You don't have the option to do that in vSphere anymore. It's all storage array thin provisioning. VVols are thin provisioned by default except for the swap. You could still choose that thick or thin if for some reason, the only really use case I could see for using thick today is if you actually, critical VM, you want to allocate all the space right away just in case the array gets short on space. You don't want something to happen to that. But we're doing everything thin pretty much on the back end of that. But if you do want that option to do thick, you can. The good thing about this now is all that space reclamation happens automatically, and that we don't have to go out, run ESXi, have it go out and try to go through chunks of storage and unallocate blocks on the storage array. If you remember what happened there with Unmap, is VMware first introduced that in vSphere 5. It was supposed to be automatic. It was supposed to be vSphere tells the host, hey, I'm done with this VM, it's deleted, it's moved, I don't need these blocks anymore, you can reclaim them. They had problems with that and issues, and that some issues around timeouts and that, so they had to withdraw that automatic support, and it became a manual process where you had to go out periodically, run ESXi or VMFS tools, and that would go out and take chunks of storage, pretty resource intensive because it had to go through the whole array essentially to see what was used and not used and bring and unallocate that storage for us. So now, because we can see VMs, we know when a VM is gone. And that, as soon as you delete it, we know that VM is gone. We can reclaim that space right away. There's no more having to wait for the vSphere to tell us that. We just simply know when that happens. So, basic operation, the VM's deleted. When I delete that VM, every single VVol associated with that VM will be deleted from the storage array, and then automatically all those disk blocks will get reclaimed because we know exactly where that VM resides on the storage array, and we can go out there and reclaim all that space. Another cool feature with Unmap now, and I think this was, at least VMware says this was kind of accidental, is they made some changes, I think, on the VM side to the drivers, and that, which now allows you to pass Unmap commands directly back to the storage array. So if I want to unmap within my guest OS, like Windows that supports Unmap, I can now unmap within the guest OS as well. I hear that's officially supported in the next version of vSphere, but it does work today in that where I can unmap within there. If I delete a lot of files, data within a virtual machine, I can reclaim that from within as well. So the impact on VAAI. So what changes is still supported, but some of the primitives changed a little bit differently. So Unmap, like I mentioned, we don't really need that anymore. So we're not doing any more Unmap operations in that. So the ones that happen within the guest get passed through, but we're not actually having to have vSphere tell us to go back and unmap space. So that one's not really used anymore by vSphere to reclaim space because it's now automatic. Block zeroing is not really used with VVols. It's up to the array vendor to decide how they want to zero blocks on the storage array. So we're not having to do that operation anymore, going through and telling vSphere all these zeros, fill the disk with that. The array will automatically take care of that. Xcopy is not used anymore for data movement and that. It's now up to the storage array to do the data movement within the array, however it needs to. The one exception to that, if I'm moving data from VMFS to VVols, that will use Xcopy simply because it's not complete within the array. We're bringing VMFS into the picture. And VVols do not use SCSI reservations at all. It doesn't support them and that. So things like RDMs, like I mentioned before, aren't really supported. And atomic test and set, which is the disk locking feature, is only used for the config virtual volume. We're not having to do that on the actual data VVols. So you want to use VVols, what do you need to do? So big one right up front is ensure your backup application supports VVols, and that you need to back up those VMs. I think a lot of them do. I know Veeam does. I know Commvault. I know Symantec do. So check with your backup provider just to make sure that they support VVols and maybe find out a little bit more on how their implementation works. And that I mentioned before, the direct to SAN backup isn't supported simply because you can't go. You have to use that protocol endpoint. That's only between the host and the storage array. So anything external is not going to be able to hit that protocol endpoint. It has to go through the host. So check with your backup vendor to see their implementation, what they support and don't support with VVols. Ensure your array supports VVols. You may need that firmware upgrade. Again, hardware compatibility guide to check that. Also, just check with your vendor to see what their support is. Ensure that your HBAs support that VVol secondary LUN ID. If it doesn't, you may have to upgrade specific drivers within ESXi to support that. If your VASA provider is external, you need to make sure it's up all the time and that. And ours is internal within the array. So if something happened, our whole array would have to go down for you to lose the VASA provider. And if our array goes down, then you got bigger problems there. So typically, I think a lot of the vendors are running them in VMs. So make sure that VM has HA. When that VASA Provider goes down, essentially you can't bind anymore. So I can't turn VMs on anymore. I can't power VMs off. The VMs that are running will still continue to run because it's only the control path for certain operations. But you want to make sure that VASA Provider is highly available. I think some of the vendors have recommendations for where you put that. You not put it within the storage container. You put that somewhere else on shared storage. You make sure HA is on there, or if you really want to go extreme, maybe put it on FT to ensure that VASA Provider is always up and running and available. Know your array capabilities are supported in VVols. So every vendor will have different feature sets that they support with VVols. Again, you'll have to ask your vendor what they support. So at the base, I think you'll find most vendors support snapshots, thin provisioning, but things like QoS, any of the array-specific features, find out what your vendor supports so you can know what you're going to get out of that, so you can use that to build your storage policies, because really the policies are all driven from the capabilities that that vendor supports. And some of the vendors you'll find early on they support a very limited amount of capabilities, and then kind of as implementations mature they'll probably add on more and more to that. But check with your vendor to find out exactly what array features they support that can be passed into a storage profile that you can use to assign the virtual machines. Understand the limitations and incompatibilities of VVols 1.0. I covered some products that weren't supported, some features that weren't supported, some of the limits that you have in that, so the number of VVols that you can support on your array. So make sure you understand what you get, you don't get. Replication's a big one. If you have to do storage array replication, you may not want to put those VMs on a VVol in a VVol storage container. Understand your array scalability, and that, again, the number of VVols that array supports. If you have 10,000 VMs on an array, and that vendor only supports 10,000 or 20,000 VVols, you're going to have a problem, because each VM is going to take up multiple VVols. Do your snapshot math, figure out how many VVols you think you're going to have, and make sure, see where your array vendor scales up to with VVols and that, so because that range can vary widely based on the vendor implementation. Check your array features that may need to be licensed. Again, make sure that you have those licensed features to be able to actually use those. Thin provisioning snapshots being the big two there. Make sure time is synced across your vSphere environment. What will happen if you don't sync your time to the same source between vCenter, the host, and the storage array? In some cases, we've seen errors where the storage container shows 0 space, and simply the time being off can cause that. I think VMware has a KB on that as well. Plan out your storage policies. Look at all your feature sets that you have and kind of put some thought into how do I want to map out these policies. If you want to create different tiers based on performance characteristics, capacity characteristics, or availability characteristics, kind of plan out, draw out the policies that you want to create and how you want to map the array features into them, and then how you want to basically assign those to virtual machines. What policies will go to what VMs. Run a small pilot with a few VMs before doing the mass migration. It's really important just to get the feel for what changes with VVols, get some experience with VVols, understand the management of VVols, and I'll talk more about the management in a little bit. There's some stuff you can do on the array, but most of it's up front on vSphere. And of course, read the manual on that. The vSphere, the vSphere storage documentation has a whole section on VVols in there, and then each array vendor probably has their own guides and best practices for implementing VVols on their array. So migrating VMs to VVols, how do we get there? I have a VMware environment, I upgraded to vSphere 6, my array supports it, now I want to start using VVols. Unfortunately, there's no magic easy button that gets you there. You can't take a VMFS volume and change it right into a VVol storage container. So we can create VVol storage containers on the same array as VMFS. So I got spare capacity on my array. I can create a VVol storage container right alongside that, and that'll get me the ability to use VMFS and storage containers with VVols on the same array. Fortunately, there's no mass migration tools available, and that you can't just again click a button and have all my VMs try to migrate to that new storage container you just created. Storage vMotion is your tool to get there, and that the VMs can be up and running while you move them, but unfortunately you'll have to move them one by one to get them over there. Some third-party tools, I think like Veeam, has a quick migration, they call it, to VVols, but they're basically doing, I think, the same thing as a storage vMotion and that. So it's a little bit difficult today to get to the VVol, to move your existing environment to VVols. Not really difficult, but more time consuming in that to kind of move those VMs there. But I think, you don't probably want to move them all at once. You probably want to start out small and just move a few VMs over there. Have them, like I said, kind of try it out and see how it all works before you start moving your entire environment over to VVols. It's recommended that you're using the latest hardware version with vSphere 6. That's hardware version 11. And I also would recommend committing your snapshots, deleting them, before migrating VMs, especially if they have memory state stored with them. I think there was a caveat around that. With if the memory state is there, you'll get some incompatibility. It'll fail or something if you try doing it. So it's best to commit those, delete those before moving them over. So implementation. So setting up VVols for the first time. This is on our array. It's fairly similar across other arrays, except for the VASA Provider piece, which if it's external, you may have to do some additional steps to deploy their appliance. On our array, basically, we're creating that VASA certificate, and that's just a security cert. We can use self-signed or vCenter certificates. You want to enable the VASA Provider service. That runs, in our case, on the storage array. So we have special command line utilities, and I'll show you on the next step how we do that to start that on the array. Create our VV set that's specific to our array. Create the storage container on those VV sets. Go ahead and create our CPGs, which are kind of our disk groups on the storage array. That's specific to us. Create our persona, and then on the host itself, you want to verify that you can see the protocol endpoint. There's a command for that I'll show you. And then in vCenter, you have to register that VASA provider. So I'm linking vCenter to the storage array VASA provider with some credentials and the data path to go there. Create my VVols storage container, just doing that once, and that's basically the whole array typically. Create my storage profiles, and then create my VMs and assign those to profiles. So let's kind of walk through that. First off, on ours, enabling the VASA provider service. Like I said, we have some specific command line utilities we developed to manage the VVol implementation on our array. We have a command, show VASA, that'll show you the status of our VASA provider, whether it's stopped or started. It'll show you some information there. I don't know if you can see it, but there's a string there, kind of a URL, and that URL is what you're going to plug into vCenter that tells vCenter how to get to the VASA provider. Basically, this is the IP of the storage array /VASA. Create your certificate. We have a command line utility for that. Then you start your VASA provider. We have a start VASA command for that. We also have a stop VASA command if you want to stop it for any reason. You can see the VASA status again. You see it's now enabled here. And then you can also see the certificate if you want. So how do I, from the host, you want to verify that connectivity actually works. There's a command, the ESXi command, //pe-only, that'll go out and query the storage array and be able to see if it can see the protocol endpoint. So what you will see there is the is VVol PE true. That means, yeah, I can see the protocol endpoint. I'm ready to start using VVols. So everything that needs to be there, vSphere 6 on the host side, the sublun support, and the protocol endpoint running on the array is all good, so it can see it, and that is true. Next, you want to register your VASA provider in vCenter. You do this for every array, or every vendor will be the same for this one. Basically, all you're doing is just putting in that URL. So here's my path to get to the storage array. Then here's my credentials to log in. So it's going to have to access the storage array. So typically, you're creating credentials, a special account on the storage array to be able to connect the two together. Then I'm creating a storage container. So when you go in to create a data store, you'll see a third option now. Instead of VMFS and NFS, you'll also see VVol. And so essentially, this is the one-time operation that I'm going to do for that array. I'm going to create that storage container on the array, and that's where my VVols will be inside that. The VASA provider will then, as you can see here, on ours, you can see that it's showing the maximum disk size. So I can see that array now. Basically, you'll see the raw capacity of the array show up there and that. So whatever's available on the array is going to be what's in this here. You'll also select the host that you want to be able to have access to that storage container. And then this kind of shows some of the command line utilities that we created to be able to support that. I already talked about some of these, how we can start and stop the VASA provider, show the status, set the properties of it. And then one key one here, which we'll show on the next one, is kind of the interaction of VVols. So the storage array admin wants to be able to have some visibility into these VVols. We have a command line utility that will display the VVols, the characteristics of the VMs, and the VVols itself. So if I ever needed to go back on the storage array and find out information about VVols, I can use that to do that. One important note, though, is you don't really want to be monkeying with VVols on the storage array side. You know, it's designed to be managed on the vSphere side, and all that workflow is all automatic. So if you start doing things like, hey, I'm going to delete a few VVols, or I'm going to do something on the storage array, you know, try to create a snapshot manually, vSphere is not aware of that. So if you start doing things on the storage array, it could disrupt vSphere because, you know, vSphere doesn't know about you doing this on the back-end storage array. So it's really not designed to be managed there, but you do have some interactivity with it. We have a command called show vvol VM that'll show you the VMs, the OS are running, whether they're unbound or bound. So you can see there it says unbound, which is powered off, and it'll say powered on when it's powered on. The number of VVols associated with that VM, which will vary, you know, from 2, typically basically when it's powered off, to multiple ones when it's powered on. Then we have another parameter on that command that'll actually show you the specific VVol. So the VVols aren't stored in directories like you're familiar with VMFS. They're all just kind of out there on the storage array. So if you have a lot of VMs, a lot of VVols, you're going to see a lot of things coming out of this command. But basically it shows you the VVol name specific to each VM, the type of VVol it is, you know, whether it's config, a data, a swap, a memory, and then how it's provisioned and how much space it's using. And that, so you can see all this information on the back end if your storage admin ever needs to go back there just to find some info on the VVols. This command's available for that. So using capabilities in the policy-based management, so on our array we support across all of our current shipping arrays, we support VVols. We had day 1 support. Our 3-part OS 321 MU2 P12 is the one we support VVols on. So what we pass over that you can use in policies is we pass hardware information, so the drive types. So things like, you know, whether it's a SSD, a nearline fiber channel, that you can then assign to policies specific to those characteristics, and the RAID level. So if you need a, you know, more critical VM on a higher RAID level, we pass the RAID level over to that you can put into a policy. We support 128,000 VVol objects. Currently, we continue to scale that up. The features that we support on ours are thin provisioning, array snapshots, auto zero detect, dedupe, unmap, adaptive flash cache, priority optimization, and we just introduced support for multiple storage containers. If for some reason you want to put multiples on the array, it doesn't really separate the space out. They're more of organizational type things when you do them on the same array. But we support multiple storage containers now and multiple vCenter servers. So essentially, when you create your storage profiles, it's just like a menu. You'll see all the capabilities that are coming up, and you can go through when you create your profile, pick and choose all those, assign those to the virtual machine. So you'll pick things like the, you know, like it shows here, the, for one, maybe I want SSDs instead of nearline. I want RAID 5. I want to enable thin provisioning. I want to enable dedupe, and whatever other features you want to enable. You all put those in storage policies. And then when you're, you then would assign those to virtual machines. So when I go and create a virtual machine, you'll see the drop down there, and those will be inside there. You can pick those and assign them to a virtual machine. It'll show the compatible storage containers that are compatible with that policy that you assigned. Here you see the only one that's a VVol one, but essentially it's going to tell you whether it's compatible or incompatible, and you can then put that on, or it'll put it on the appropriate one. You could also, another cool thing is if you have a VM with multiple disks, you can assign different policies to the different disks. So if I wanted my data disk on an SSD tier and I wanted my OS disk on a nearline tier, you could do that. So you can assign these storage policies specific to individual virtual disks as well. So why would you want to implement VVols now? I know a lot of people hold off and, you know, kind of wait when some of these new features get introduced, but I think there's a lot of compelling reasons on why you'd want to start today using VVols. Big thing is it's not all or nothing. You know, with VVols, you don't have to jump everything over to VVols. You can go at your own pace. You can move if you only want 1 or 2 VMs over there. Try it out. You can do that. Storage vMotion them over there. If you want to bring them back, you can bring them back. You know, if you have VVols and VMFS, you know, running side by side, you can go back and forth. So you don't have to make the whole jump into the pool. You can kind of dip your foot in and try it out, and kind of take your time, get comfortable with it, and once you know and understand it, kind of make the more of a more migration to that. Early experience with VVols, a lot of times, VVols will eventually replace VMFS, and that VMware never keeps two of anything around. ESXi, the vSphere client still lives on to this day, but eventually that'll go away. Same with VMFS. VMFS eventually will go away. And so, getting the early on experience with it, not waiting until the last minute to have to learn this whole new storage architecture, getting your hands dirty now, I think will benefit you later on. Getting that disk space back is a big one. You're not having to worry about going out and reclaiming space manually when you need to. The array is always going to be as efficient as possible because it knows to reclaim space when it needs to. It's available in all vSphere editions. This isn't really a feature. It's a key architectural component of vSphere. So no matter what edition you have, it's going to have VVols support. Letting the storage array do what it's do best. For a while there, we had to. vSphere was micromanaging everything storage related, and that we're passing things back and forth between the array and and vSphere. And the storage engine, the array is really an I/O engine that is designed to do all this stuff. So letting the array do everything is just a lot more efficient. We're not burdening the host anymore. Let the host dedicate its resources to its workloads. Let the array do what it's do best. Start using storage policy-based management now. The vSAN users have had this for a while, and that engine that really, I think, gets you a lot of benefits with these policies, being able to create those, have better SLAs, assigning them to virtual machines. You can now finally start using that, with VVols, where you can't use that without it unless you have vSAN. Snapshots, they're not going to suck the life out of your host anymore. Snapshots were always a resource-intensive operation. Some people create lots and lots of VM snapshots. They sit there, they take up resources. You delete them. When they commit back, they take up resources. So you're really a lot more efficient. You're saving a lot of host resources by shifting all that to the array. It's easier for generalists, and that, again, you don't have to be a storage admin to really use this, and that you're managing everything. That vSphere admin can manage everything in vSphere. You're not having to go back to the storage array to do things all the time. One architecture, and that this really levels the playing field when it comes to protocols. If you're familiar today, we have NFS clients we have to run on the host, iSCSI initiators. No longer, it's all the protocol endpoint, and that's all it is. Everything goes through that protocol endpoint. So the protocols are really on an equal basis because they all have to conform to this VVols architecture. So what protocol you use really doesn't have that much impact anymore. It's really about the architecture and the storage array, and the protocol is just the method of getting your data from the host to the storage array. The big one is, the VM is now a unit of storage. So, we can see from the storage array virtual machines and be able to interact with them directly and apply any type of feature to a virtual machine. So the big one there, I think, is that we can do this. This is what it's all about, essentially, getting that application and VM level granularity and be able to have the storage array, kind of bridge that gap to the VMs and interact and apply feature sets directly to those virtual machines. Just one slide on our implementation and that. With us, like I said, we're built into the array. You don't have to install anything. If you have our latest firmware, you already have your VVols ready. Nothing really to do there. Because it's within the array, we don't have any external failure points. You don't have to worry about a VM, somebody accidentally shutting down your VAS provider on a VM. It's always in the array running. You don't have to worry about that failing. We were a design platform for reference platform for VVols, one of the design partners. So we've been working on this for 5+ years and that, so we have a lot of experience. Our implementation is pretty mature. We have a lot of rich data services that we can now apply directly to VMs, and our efficiency with our thin provisioning, our thin dedupe, you can apply directly to VMs. And one thing we kind of do unique, and I don't think a lot of other implementations do out there, we allow you to do snapshots on different storage tier from your VM. So maybe you don't want those snapshots on your SSD tier. You want to dump them onto a different tier. We allow you to do that. We have some information. If you want to know more, we got a really good white paper that covers all the components of VVols, how to implement it on 3PAR. A lot of great information in there. We have one specifically on snapshots as well. That mechanism has changed a lot with VVols. So we have a paper there that kind of details the changes and how to interact with snapshots differently with VVols and on our array. And that, again, that's kind of general in nature. That can apply to other arrays as well. So that's another good read to learn more about it. A few more minutes left. So any questions at all? And there's some mics in the middle if you can. Otherwise, I can repeat the questions.
Yes. Could you comment on the ease or the difficulty at the current maturity of the technology in migrating, once you're into this world and assuming all your hardware is compliant, migrating between storage arrays within the same vendor, and also if you're refreshing and changing vendor, migrating from one to a new vendor?
Yeah, a lot of that's going to be using the same, like storage vMotion, for example, and that going from one specific array to another. That'd be kind of your go-to tool for doing that. Within vendors, I know we specifically have some within array or between array tools that allow you to migrate data from one array to another. So depending on what side you want to do it on, if it's different arrays, obviously you have to use the vSphere tools or some other third-party tools to move your data back and forth. But essentially, I don't think that's really is too VVol specific. You're going to be doing that anyway if you're changing from one array to another array, and basically using some of the same tool sets to do that. Any others?
With Horizon View 6.1, I believe there's some support for VVols. Can you speak to any advantages of VVols in an Horizon View environment?
Oh, the question was, you said around?
VMware Horizon View?
Sorry.
Link clones?
Oh, link clones? Okay.
Yeah.
I'm not sure on the link clone side. I haven't delved into the VDI side too much on that, and I'm not sure if, on that one, I'm not really sure on the VDI side on how that implementation would be done. I haven't seen too much information out there either on VDI and VVols. So.
And one quick follow-up question with storage vMotion. You mentioned that the objects in VMFS are different in VVols. Is there some sort of conversion process in the storage vMotion, or does it keep intact the VMX files and things like that as it goes?
So when you're doing the storage vMotion?
Yeah.
So basically, when you're doing the storage vMotion, that's at the vSphere layer. It's a copy operation. And essentially, it's the engine that's taking the data off of one data store, moving it to the other data store. So it's automatically, essentially, taking it out of those traditional files on either block storage, VMFS, NFS, and moving them to a VVol. So that's how it's getting kind of converted, is through the storage vMotion process, which is essentially the data mover above the array level. It happens at the vSphere level. So it's simply a copy operation. Simply, if you're copying anything from one to another, that's what the mechanism that would be to get the data to go from one to the other and make sure it's in the right format when it lands there.
Great, thanks.
Are policies associated with storage containers? So if I want a gold that's fast RAID 10 and bronze that's slow RAID 6, is that a different storage container, or how is that implemented?
No, it's all basically one storage container per host. What that comes, like in our case, when we create different kind of disk groups, CPGs on our end, they'll have those characteristics like the RAID 10 or RAID whatnot, and those are all within the array, all within the storage container. We're not creating separate storage containers based on those capabilities. Those are all independent of it, and essentially those all live within and are available within that single storage container. What's that? The disk group, not on the SAN. The disk groups on the SAN, are within that.
Is the 3-PAR recovery manager for VMware supported with VVols?
I believe very soon. There you go. There's the answer. October.
October, okay.
Coming very soon.
How about peer persistence, adaptive optimization?
AO today, no. We don't support it as a capability that you can use with VVols. Peer persistence, do we, Bob?
Well, regarding AO, you can choose a disk group that supports AO, and it'll do AO.
So it's on the back. You can't use it in policies, but on the array you can.
You can use it in the policy by selecting the disk group.
Okay.
But peer persistence, no, not yet.
And that would tie in, what about the VASA provider when you have more than one 3-PAR with obviously remote copy on it? How will that work, or when will that work?
Well, each array has its own VASA provider, and that essentially connects to vCenter server. So every single array you'll have its own VASA provider and essentially one vCenter server. Each vCenter server, we support multiple vCenter servers now as well. So that connection essentially is, however it needs to be.
So you would have to wait until peer persistence is available for that before you can do something like a fault-tolerant solution across more than one 3-par?
So until replication is supported, once you have a solution that supports replication, the remote VASA provider can provide the support to the remote site. And it doesn't need to be tied in. But if you're looking for a solution that presents 2 arrays as if it were one, then yes, the VASA providers have to know about each other and know how to present the 2 arrays as one. So that's not there yet.
And is there a roadmap for that, or?
It's on a list.
Coming soon.
Couple questions. One, I saw that 3-par supports 128,000 VVols. Is that including snapshots or just only VVols?
What was the question again? Something about 3-par and snapshots?
Oh, you said it was 128,000
okay.
VVols.
That's includes snapshots. So
Includes snapshots also.
Any object of the VVol. So again, the VMs have multiple VVols. That's all aggregated into that 128,000, and that's up to what we support.
Okay, great. And the second question was around, do you have VSS provider to back up, using application consistent backups with VVols?
Yeah, that's within the VASA provider. Typically within your backup application or the VM itself. There's nothing really specific to the. You're talking about the VSS?
Yeah, the VSS provider.
Yeah, that's not really specific to VVols there at all. And that continues to operate how it does today, regardless of it being on VVols or VMFS.
Okay, thank you.
So SRM is not supported, and I believe you said that array-based replication is not supported either. So what should be your DR strategy when implementing VVols?
Well, yeah, SRM specifically isn't supported, and that's VMware not supporting it. Same with VMSC. Some of the array vendors support replication, and that outside of it, they're doing it on their own between arrays. I know at some point we'll be supporting replication as well. You could also go above the array. So if you want to implement a third-party replication solution like vSphere replication, Veeam replication, Zerto, that operates above the array level. So it can replicate data simply because it's working at a higher level. It's not working at the array level. So a solution like that for now that'll get you through until the VASA 3.0 specification officially supports replication within the array. Or like I said, if your array supports replication, outside of the policy-based management, that again would get you, some DR capabilities there.
Okay, thank you.
Sure.
Of those 120,000 VVols that you support, how many are volumes and how many are snapshots?
It's whatever, they can be anything, essentially. So, any single VM is going to be multiple.
So if I wanted to, I could create 120,000 volumes?
Well, you couldn't create 100.
With no snapshots?
Well, no, those are getting created automatically when you create your VMs and that. But based on the number of VMs, the number of VVols under that, those all add up and aggregate into the total amount of VVols that we support. Okay, I think if you want to do more questions, I'll go in the back of the room. We can ask more questions.